We'll start in a minute. Okay, I heard the alarm. Today we'll be in section 5 of chapter 9. Both today and tomorrow we'll look at problem solving with quadratic equations. So that means we'll be solving word problems. So a general problem solving strategy that we'll apply, read the problem and try to understand all of the words and the ideas. Identify what needs to be found. In algebra, we pick a variable to represent each quantity that needs to be found. And then using the variables and the given information, we formulate an equation. And then we solve the equation using algebraic properties. And then afterwards, we can check the answer to verify that it makes sense. Okay, we'll look at some problems that have a similar, we've seen similar problems before, but some of these will work out a little bit differently. This first one is very much like one that we've already done. The product of two consecutive positive odd integers is 143. Find the integers. The numbers are small enough that you could just experiment and find the two consecutive odd integers that have a product of 143. But what we're trying to do is develop some algebraic techniques so that we can solve problems with bigger numbers. So in other words, the goal isn't simply to find the two numbers. The goal is to read the problem, understand it, identify what we're supposed to find, formulate an equation, and then solve the equation. Okay, if we have two consecutive positive odd integers, we want to represent those. So we can pick x to be one of those odd integers. And then the next integer that comes after, the next odd integer that comes after x is x plus 2. So in other words, odd integers differ by 2, so we can represent consecutive odd integers as x and x plus 2. And then the product is 143, so when we multiply x times x plus 2, the product is 143. And this is a quadratic equation. So we'll solve it by using the quadratic formula. So multiply x times x plus 2, we get x to the second plus 2x equals 143. Set one side equal to 0. So we get x squared plus 2x minus 143 equals 0. And then we'll proceed to solve this by using the quadratic formula. We could solve it by factoring, but but we're practicing the quadratic formula. So a reminder, the quadratic formula, I'll write that up here at the top. So hopefully you've memorized this by now, but for now we'll have a reference. The solutions to ax squared plus bx plus c equals 0, or x equals negative b plus and minus the square root of b squared minus 4ac, all divided by 2 times a. Okay, so for this particular quadratic equation, the value of a is 1, b is 2, and c is negative 143. Okay, so x equals negative b. B is 2, so x equals negative 2 plus and minus the square root of b squared minus 4ac, so 2 squared minus 4 times 1 times negative 143, and then all divided by 2 times 1. So then we do the arithmetic inside the square root. So 2 squared is 4, and we're subtracting 4 times 1 times negative 144. So we're going to be adding, since we're subtracting a negative, so 4 times 143 is how much? 562?
572.
572. So we're subtracting negative 572. Okay, then negative 2 plus and minus the square root of 576. 4 minus negative 572 is 576 divided by 2. The square root of 576 is 24. So negative 2 plus and minus 24 divided by 2. This equation has 2 solutions. One is positive and one is negative. But we want the positive solution. So we'll pick the solution we get when we add negative 2 plus 24 divided by 2. And negative 2 plus 24 is 22. 22 divided by 2 is 11. Okay, so one of our numbers is 11. The other one is x plus 2, which is 13. So 11 and 13, they are obviously consecutive odd integers, and we can verify by multiplying that the product 11 times 13 is 143. I wanted to save this space right here to show you that we can easily solve this equation by completing the square. So we have x squared plus 2x equals 143. And then to create a perfect square trinomial, we take 1/2 of the coefficient of x and square it. So 1/2 of 2 is 1, and 1 squared is 1. So if we add 1 to both sides, we get x squared plus 2x plus 1 equals 143 plus 1. And then x squared plus 2x plus 1 is a perfect square trinomial. When you factor it, it's x plus 1 to the second equals 144. And then apply the square root property, we get x plus 1 equals positive and negative square root of 144. But the square root of 144 is 12. And so we get two solutions. X is negative 1 plus and minus 12. We want the positive solution for x, so x equals negative 1 plus 12, or 11. So I just pointed that out because this is solving this one by completing the square is easier than some of the other ones that we did that involved fractions. Okay, let's move on to the next problem. The area of a triangle is 136 square feet. The base is 2 feet longer than 4 times its height. So this word "the" shouldn't be there. The base is 2 feet longer than 4 times its height. Find the base and height of the triangle. Okay, so we need to know the formula for the area of any triangle. So any triangle whatsoever, I'll just draw a triangle. So every triangle has 3 sets of bases and heights. So one set, if we refer to the length of this side as the base, then if we construct a line segment from the vertex opposite of the base so that that line segment is perpendicular to the base, then that line segment is the height of the triangle. And it turns out that the area of a triangle is 1/2 times the base times the height. So for any triangle, the area is 1/2 times the base times the height. Okay, so we're given some information about a triangle. We're told that the area is 136 square feet. And we're told that the base is 2 feet longer than 4 times its height. So since the base is described in terms of the height, my general strategy is, in that case, assign a variable to represent the height. So I'll use x to represent the height measured in feet. So x feet is the height. And then I'm going to write an expression for the base in terms of x using the second sentence. So the base is 2 feet longer than 4 times its height. Okay, the height is x feet, and so 4 times that is 4 times x. And 2 more than, or 2 feet longer than 4 times x is 4x plus 2. So this is how I'm representing the base. And then after you make the variable assignments, you can look at them to see if it makes sense. It seems to make sense. The base is 2 feet longer than 4 times the height. Okay, then we use the area equals 1/2 base times height formula to get our equation. The area is 136 square feet. So we'll just write the number 136. We'll leave the units out when we're using the variables and the numbers. Okay, 136 is the area. That's equal to 1/2 times the base times the height. So 1/2 times the binomial 4x plus 2 times x. This is a quadratic equation, so we can get it into standard form, and then we can use the quadratic formula to solve it, or we can solve it by completing the square. Hey, we have a couple of options here. One is to multiply both sides by 2, just to get rid of that fraction. So if we multiply every term on both sides by 2, we get 272, and then 2 times 1/2 is 1, and then we have equals 4x plus 2 times x. And we will go ahead and multiply 4x plus 2 times x to get 4x to the second plus 2x. And then we'll write this in standard form. So I'm going to subtract 272 from both sides. And I'll put all of the terms on the left-hand side. So we'll get 4x squared plus 2x minus 272 equals 0. That's equivalent to having 0 equals 4x squared plus 2x minus 272. Okay, another thing that can make the arithmetic simpler is notice that every term has a common factor of 2. So we can divide every term on both sides of the equation by 2 to get rid of some of the clutter that's in the way. So divide every term on both sides of the equation by 2. We'll get 2x to the second plus x minus 136. And 0 divided by 2 is just 0. And now we can solve this equation by using the quadratic formula. So for this quadratic equation, a is 2, b is positive 1, and c is negative 136. Okay, so the quadratic formula, we'll apply that. X equals negative b, so b is 1, so x equals negative 1, plus and minus the square root of b squared minus 4ac. So 1 squared minus 4 times 2 times negative 136, all divided by 2 times 2. Okay, I'll point out something here that we can look for whenever it's applicable. So notice inside the square root, we're going to have 1 minus a negative number, so that will be 1 plus a positive number. So in other words, we're going to get the square root of a positive number. One of the solutions is negative. Negative 1 minus a positive number is negative. So we can ignore the solution that we're going to get by subtracting, because in this problem, our quantities need to be positive. So just for convenience, I'm going to omit the minus from now on, and we'll just focus on negative 1 plus the square root of that number divided by 4. Okay, so x equals -1 plus the square root of that positive number. So 1 squared is 1, and we're subtracting 4 times 2 times -136. So that's going to be plus 1088, I believe. Right, 8 times 100 is 800, plus 240 is 1040, plus 48 is 1088. And so this is -1 plus the square root of 1089. 1089 is a perfect square. The square root of 1089 is 33. Yeah, I think that's right. So we get x equals -1 plus 33 divided by 4. -1 plus 33 is 32. And 32 divided by 4 is 8. Okay, so the height of the triangle is 8 feet. So the height is 8 feet. The width, not width, sorry, base. The base is 4 times x plus 2. 4 times 8 plus 2 is 32 plus 2, or 34. And we can verify that we have the right numbers. We can check our answer using the formula for the area of a triangle. So the area is given to be 136. And we want to know if it's equal to 1/2 times base times height. So 1/2 times 34 times 8. 1/2 of 34 is 17. And 17 times 8 is 80 plus 56, which is 136. So it appears that everything checks out on that one. Okay, the next problem on the next page . This one, working together, Bertram and Florence can clean their shop in 2 hours, working together. When each works alone, Florence takes 3 hours longer than Bertram. Find how long it takes each to clean the shop alone. Hey, this is a work problem. Remember what form the equations are for work problems. So there is a task that they are working on, one job or one task. So the equations have the form rate times time equals 1. Same as what we saw a few weeks ago, or however long it was. So for work problems, when they're just doing one job or one task, the equations have the form rate times time equals 1. Okay, so we're told how long it takes Bertram and Florence to do the job when they work together. They can clean the shop in 2 hours. And when each works alone, Florence takes 3 hours longer than Bertram. So find how long it takes each of them to clean the shop when they're working alone. So we can assign, or we can, we'll assign variables for the quantities that we're supposed to find. So we're supposed to find how long it takes each of them working alone to clean the shop. So we'll pick a variable to represent one of the two times and then use the information to write down an expression for the other person's time. We have options, but some options are, in my opinion, are more convenient than others. Notice in this sentence, it says Florence takes 3 hours longer than Bertram. So the way I look at it, since the amount of time it takes Florence is described in terms of the amount of time it takes Bertram, if I pick a single variable to represent Bertram's time, then I'll use that and the other information to come up with an expression for the amount of time it takes Florence. So I'm going to pick capital T for the number of hours it takes Bertram to do the job, hours it takes Bertram. And then we're told that Florence takes 3 hours longer than Bertram. So what do we represent for the amount of time it takes Florence to do the job?
Maybe T plus 3.
T plus 3, yeah. Since Bertram takes T hours and Florence takes 3 hours longer than Bertram, we can represent Florence's time by T plus 3. So hours it takes Florence. Well, when they work together, we're told that they can complete the job in 2 hours. So 2 hours when working together. Yeah, I'm writing down more information than is necessary, but it might help if you struggle with these problems. Okay, so now we're going to write down 3 equations, each having the form rate times time equals 1. One for Bertram. So Bertram's equation. Bertram works at a certain rate. I'm going to refer to his rate as R sub B. And in T hours, he can complete one job. He can clean the shop. In T hours, Florence works at a certain rate. I'm going to refer to her rate as R sub F. And then the amount of time it takes Florence is T plus 3 hours to clean the shop. So here's our rate times time equals 1 for Florence. And when they work together, Bertram works at his rate. We add that to Florence's rate. And in 2 hours, they can clean the shop. So rate times time equals 1. Okay, then we solve each of the 3 equations for the rates. Bertram's rate is 1 divided by t. Florence's rate is 1 divided by t plus 3. And the sum of the rates, Bertram's rate plus Florence's rate, is 1/2. Okay, so we combine the results of these three equations to get an equation whose only variable is t. So for all of these word problems, after we assign variables, we want to get an equation whose only variable is one of the assigned variables. So we can do that if we replace Bertram's rate in this equation with 1 over t, replace Florence's rate with 1 over t plus 3. The sum of the two rates is 1/2. Okay, we've seen equations like this before, an equation with rational expressions. So the one technique is to find the least common multiple of the denominators, called the least common denominator. So the least common denominator is 2 times t times the binomial t plus 3. And then we multiply every term on both sides of this equation by the least common denominator. Okay, I ran out of space, so I'm going to get a blank piece of paper. I'll write this equation down and then we'll solve it. Okay, so here's the equation. And on this piece of paper, we have more room. Okay, we multiply every term on both sides of this equation by the least common denominator. So 2t times t plus 3 over 1 times 1 over t. And then 2t times t plus 3 over 1 times 1 over t plus 3. On the right-hand side, 2 times t plus 3 over 1 times 1/2. So we get cancellations. So in this first product, the factors t cancel. One factor of t from the numerator cancels with t in the denominator. In the next product, the binomial t plus 3 divided by t plus 3 is equal to 1. Those cancel. On the right-hand side, the factor 2 from the numerator divided by 2 in the denominator, those cancel. So we write down what's left. Here we have 2 times the binomial t plus 3. Here we just have plus 2t. On the right-hand side, we have t times t plus 3. So this equation is a quadratic equation in the variable t. So we'll multiply everything out, combine like terms, write the quadratic equation in standard form, and then we can solve it. So we'll subtract 4t from both sides and subtract 6 from both sides. So we get 0 equals t to the second minus t minus 6. We can pretty easily solve this equation by factoring. So in general, you can use any method that you want to solve a quadratic equation unless you're taking a test and the directions tell you to use one method or another. So if we just look at the two factors, one factor is t minus 3 and the other one is t plus 1. So since t represents time, the solution that's positive is the one that makes sense. So Bertram takes 3 hours and Florence takes t plus 3 hours or 6 hours. But why don't we practice the quadratic formula? So A is 1, B is -1, C is -6. So the quadratic formula for the two solutions for t are -b plus and minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, so for this one, since b is -1, we have the negative of -1 plus and minus the square root of the number -1 squared minus 4 times 1 times -6, all divided by 2 times 1. Then arithmetic. The negative of -1 is 1, plus and minus the square root of a number. The number -1 squared is 1, and we're subtracting 4 times 1 times -6. We're subtracting -24, all divided by 2. So 1 plus and minus the square root of 25. 1 minus -24 is 1 plus 24, or 25. So 1 plus and minus 5 divided by 2. Okay, we want the solution that's positive, so 1 plus 5 divided by 2 is 6 divided by 2, or 3. Okay, that's the same result we got when we solved it by factoring up here. Okay, let's start the next problem, number 4. Take a couple of minutes to see if you can set up an equation to solve for the quantity that we're supposed to find. Well, let's start this one. What kind of equations do we need for this one? This involves uniform motion, so rate times time equals distance. Equivalent to rate times time equals distance. Rate equals distance divided by time. Also, time is equal to distance divided by rate. So each of those three equations is equivalent to the other two. And we use the ones that are described in the problem itself. Okay, we're told that in a total of 5 hours, an airplane flies 300 miles with the wind and 300 miles against the wind. With no wind, the airplane flies at 125 miles per hour. So find the speed of the wind. So we're only supposed to find one quantity, the speed of the wind. So I'll pick X, wind speed. So X miles per hour. Well, the airplane flies into the wind, or the first one described is with the wind. So the airplane flies with the wind, and then after that, it flies against the wind. Each time it flies a distance of 300 miles. And the total amount of time to fly 300 miles with the wind and 300 miles against the wind is 5 hours. So we can write an equation for the airplane flying with the wind. Then after that, we'll write an equation for the airplane flying against the wind. And then we'll go from there. So with the wind, well, if there was no wind, the airplane would fly at 125 miles per hour. But if it's flying with the wind and the wind speed is X miles per hour, the speed of the plane will be, or the rate will be 125 plus X miles per hour. This represents the rate when it's flying with the wind, where the wind speed is X miles per hour. And the airplane, if there was no wind, it would be flying at 125 miles per hour. The actual amount of time it takes to fly 300 miles with the wind is not given, but we can represent it. I'll represent that amount of time as T sub W for the amount of time that it was flying with the wind, and the distance is 300 miles. So we have an equation that has the form rate times time equals distance. Hey, then when it's flying against the wind, that is, it's flying into the wind, how fast will the plane be going? If there was no wind, it would be flying at 125 miles per hour. So if it's flying against the wind, the speed will be 125 minus x miles per hour. And that particular amount of time that it takes to fly 300 miles against the wind, that particular amount of time is not given. So let's just represent it by T sub A for the amount of time it flies 300 miles against the wind. So we have another equation that has the form rate times time equals distance. Okay, we want to find the wind speed. We are using x to represent the wind speed. What we need is an equation whose only variable is x. So how do we get there? How do we get to that equation? Okay, the information that we're going to use next is the first part of the first sentence. In a total of 5 hours, an airplane flies 300 miles with the wind and 300 miles against the wind. So the amount of time it flew 300 miles against the wind is represented by T sub W. The amount of time that it flew 300 miles against the wind is represented by T sub A. We're told that the total amount of time to fly 300 miles with the wind plus the amount of time it takes to fly 300 miles against the wind is a total of 5 hours. So yeah, we made these variable assignments for time, but we're given information about that. We're given that the total amount of time, T sub W plus T sub A, is 5 hours, right? That's given in the first part of the first sentence. Remember what the goal is. The goal is to get one equation whose only variable is x. We're going to use these 3 equations to get us there. So solve this equation, the 125 plus x times T sub W equals 300. Solve this for T sub W. Remember, time equals distance divided by rate. So the time it took to fly 300 miles with the wind is equal to the distance, 300 miles, divided by the rate, 125 plus x miles per hour. Solve the other equation for its time. Time is equal to distance divided by rate. So the amount of time it took to fly 300 miles against the wind is equal to the distance of 300 miles divided by the rate, 125 minus x miles per hour. Okay, then we substitute these expressions in the variable x into this equation. Since T sub W plus T sub A equals 5, we get 300 divided by 125 plus x plus 300 divided by 125 minus x equals 5. So we finally have our equation whose only variable is x. So we're running out of time, but you know how to solve this. The least common denominator is just 125 plus x times 125 minus x. The numbers are sort of large, but they're not that hard to work with. This will turn out really nicely. Multiply every term on both sides by the least common denominator, and then solve the resulting equation for x. So it's now 8:50, so tomorrow we'll work on the rest of the problems